everyone. In this video, we'll talk about a CI/CD process using GitHub as Actions as a platform and develop a microservice application where each individual application is an independent deployment. And we're going to deploy the application to Kubernetes. The Kubernetes application is using Oracle Cloud Managed Servers. Let's get started. So first off, the application is composed of 5 microservices. So the main application, the main API is a Micronaut application. There is a UI application, which is an Angular-based user interface. There is the mobile application, which is a Ionic-based with Angular user interface. Is a mobile application. Is a PWA application. And there is a triggers and events applications. The triggers and events applications are responsible for events. It consumes streaming servers using Kafka applications. The triggers receives a webhook with payments, and it performs database operations like consolidated the stock, and the event the server send event to the user saying that the payment is done. That's the application, but it doesn't matter too much what the application do, because we're gonna focus on the CI/CD process. So first thing, let's see the API. What we have here, we have a GitHub workflow. The first workflow that we're gonna see is the pull request workflow. The pull request workflow just builds the application. So it's responsible for caching and running the application using Gradle. And if the build has a success, it sends a notification to ClickUp, using ClickUp as a chat application and also as a task manager application. So every time a build is successful, there is a message here for us to follow the build. So there is also a task for test coverage report that I'm not using anymore, but it's here, that sends the test coverage to their deep source analytics system. But the main point here is the building of the application. This only happens if the pull request is open, reopened, or synchronized, and it's only happen if the target branch is the main branch. Now, the deploy application is where this CI/CD happens. It happens only in the main branch. So when I open the pull request, send it to the main branch. We can check here into the pull requests. Let's see pull requests that have been closed. Let's check this one. So when I open the pull request, it opens the build. It builds with the Codana for JVM that do analyze into the system. So this Codana, it's another workflow here. Let's say it's a jobs that has a Codana workflow. So, and it also builds the system. And my point, we can do the basically pull request workflow here, analyze the pull request, and we have the checks here where the pull request has the build process and it passes the build process, and also the test coverage report. Okay, so once the pull request check are done, we merge the code to the main branch, and that's when the CI/CD start to happen. Just as a curiosity here, I merged the pull request using one workflow as well. I comment here fast forward dispatch man. Once I comment fast forward, I will do a fast forward because GitHub has only 3 options for merging, and I want to preserve the GPG signature for my user, and none of the options to merge the code in GitHub, doing a rebase or doing a merge comment, none of them preserve the GPG signature of the user. I want to do that. That's why I create a fast forward that will not merge or create a new comments on the branch. So I created this command here, and it triggers a fast forward. Now, just a curiosity. Once the pull request is measured, it will dispatch an action into the main branch. For example, this is the last one. This action has some interesting steps. First, it determines a version. The version, it's based on the date. So let's check the release date. So is the date V 2025 5/26. And if the first version is created, it adds a .1. And if it's the second version released in the same date, it adds a .2 and so on. How it knows the version that has been released, because this version also is a tag. So this version is also a tag into the system. We can check here into the tags, and we have all the tags here. Now, let's check the action again. Determines the version, then builds the image. It logins to the Docker Hub and logins to the Hub application, the OCI application. The OCI is the container register for Oracle Cloud. It's this repository here where I have the images. You can see that our images are pushed here. So it logs into the OCI register. It builds it updates the project version. It updates the version here into the build system, to the Gradle. Every technology will have a way to do so. The way I'm doing so is adding the version here. It's the easiest way for me to update the version. And I reference the version here in the build of the Gradle. So the application version has the new version. So then it builds and push the image to the register. So it builds and push the image to the register. Now, to build and push the image to the register, there is many ways to do so. One way to do it's using the Micronaut native build of Docker images, so you don't need to have a Docker file here. So the way I'm doing here, it's configuring the task in Gradle that will generate the image here, Docker build image. The image name has to be the same as the register, so you have to override here so I could push the image to the register. And that's it, to build the native image if we're building a native image here. though without using JVM. And once we build the image, we can push to the register. And we push to the register and we notify that the action is done. Now, after the action is done, we release the code. Now, the interesting part here is that after the push the image, I release the code. What this mean? This means that I update the readme with the new image version, and I sign in a commit with the new version. So the new version is from the last stage of the build, and then I commit this new version into the project. So I have to do that, and the commit message has to have a skip CI so you don't end in the infinite loop here. Let's check one of these commits here. You can see that it's an automated change, deploy version, skip CI. So this will not trigger a new CI deployment inside the main branch. And this is done by the user, but you see that it doesn't preserve the JPG signature of the user. Now, this is not possible to do in GitHub. Now, with the comment message, we could release the code. We also add the test coverage report here, but we could start the staging deployment. This staging deployment, we just fire an event here. The event is a core for the GitHub API. This core will trigger the new pipeline in a new project. So let's recap what we have here. We determine the version, build a Docker image and push to the register. Then we release the code in creating the tag in the repository and commented the new version into the repository into the code. And then we start a new event in a new repository. This new repository, it's a Helm chart repository. Let's check this repository. This is the Helm charts. Now the Helm charts, I would trigger an action here. This action is a dispatch event action. This is start a deployment, and it receives some parameters. The first parameter is the version, the name of the application, and the environment that is this deployment is starting. Now, what it does, it starts a script that will deploy the application with the app, the version, and the environment. First, it will tag the deployment with the app name and the version and the environment. So it's a simple script. What it will do, every app, it's an application folder, and it will get the values from the Helm chart with the environment. So if the environment is the seed environment, is for testing. Let's suppose we are deploying this application. It will get the value seed application, and then it will update the version tag. Just it will update the version tag, and it will commit a new. After that, it will commit the application. So let's check the GitHub workflow for this, the update version. So it will check the parameters, it will check out the code, it will run the tag that will update the tag, and then it will run the deployment of the tag, and then it will commit the new version for the shard. So let's check the shard version commits here. If you can see, it's the automated deploy. You can change the shard manually as well. That's no problem with that. And we have automated comments here with the versions. So what will happen after you comment? You're just updating the Helm shard. So let's check the Helm shard application. API, we have values for each environment, and we have templates. The templates will get deployed to the Kubernetes. But how these templates will get deployed to Kubernetes? And then it enters the GitOps ArgoCD application. Let me check if I have the GitOps system. What it will do, it will keep listening for new comments inside the Helm charts GitHub Git, and it will triggers a reconcile, and will in this reconcile cycle it will get the difference between the Helm charts and would apply the difference into the Kubernetes system. So using Helm, it will keep refreshing and adding the new application, the new configuration to the system. So let's check one here, the API. For example, the API, it has all these configurations. It has a secret provider with the secrets for the application. It has a HTTP route with the Ingress application, so we can reach the API from external system. And it has a secret for the database, and it has the pod with the container that we will run inside Kubernetes. And if you check here, you can see that it's just a pod definition for the application. You can even see the logs for the system. I recommend that you use logs in JSON so you could capture these logs later and read this in the centralized system. So you can even see the logs here, but it's not a good way to see the logs because you will lose the logs frequently, right? So you have to capture it and send to a system. By the way, I'm using the OCI, the Oracle Cloud login system to capture these logs. It has a managed system that you don't need to worry about installing anything. But yeah, it will keep reconciling this. So let's check one. This is an action. All this happens the same for our applications. So if I send an events application, it will do the same. If I send the mobile application, it will do the same because it's just an Nginx container with the files, right? The UI as well. The UI, and he has the Docker file, so no problems with that. Let's check the Docker file. Just creating a web server with the files after a build of the Angular application. Now, let's see that in action. I would like to change something here. Let's say I would just update the index file, and I would just remove a line here. I'll do a comment. I will do a comment directly into the main, so I don't need to add create a pull request here, so we can do it quickly. But in a normal system with a theme, you will have a pull request for this change. So let's check here, demo video for CICD. I will comment and push. The application. Now, what will happen? First thing that will happen it's the action. It will release the seed. Now it will build and test the application. Let's check if this building is correct, because I altered this application. And let's see if the build will pass. Passes the lint for the application. It's the TypeScript lint. Now the building test will run some tests, install the dependencies, and run tests. Okay, all tests passed, and it is uploading the results reports. And when I upload the results, I save it here somewhere. Like here. And the upload the results, I have the artifacts and the reports here, so I can check the building reports if I need, if it fails or not. Now I start building the image. When I build the image, it will get the release version, and to build the image, we'll log into the OCI. Again, the same partner here. Build the image, log in, and push the image. Now that it has built the image, it will release the code. So it will comment the new project version and release a new tag. In my case, I do one I do another thing here. Since the application it's basically not released and it will be for a long time not released, to not have too many tags here, I have a cleanup job inside GitHub. So this cleanup job, it's here. GitHub cleanup releases. So every Monday, Wednesday, and Friday, it will get the 20 days later. Everything that is older than 20 days will get cleaned up and will keep the last 4 even if it's older than 20 days. So that way it doesn't keep too many versions here that are not released, right? If it's a pre-release, it will clean up. But if it's a release, it will not touch it. So if you release application, it will not touch. So let's check the action. Okay, it's start the station deployment. Let's check the application, the UI. It will eventually trigger a new, check this here, an hour ago. That's the last pod running. It will be quicker because the application it's lighter, right? So it's a UI application, doesn't have, it's not a backend, but it will be quickly to update. But it will do a sync every 30 seconds. And let's check the Helm charts. It did dispatch event 2 minutes ago. Deployment, show the parameters. Is the UI application in the SIT environment. This is the version that have been built in the last step of the cycle, the workflow. So let's check. We can just wait here, just sit and wait, and eventually, okay, it started the sync, and now it creates a new pod and substitute the pod. It was very quickly. Okay, so the pod, it's new pod with the version of the system. Let's check the version. Yeah, the new version and the image of the image. Let's check the logs, and it's already serving the new application. So that's it. This is the complete overview of a full workflow for deployment of applications in the microservice way. So each deployment is independently, and it happens as soon as you publish code. This is also called the main trunk developer release cycle. What happens if you want to test the application before releasing? This is releasing application as soon as code is done, right? This is not a production environment that get released. First get released to SIT environment. SIT stands for system integration, and this system integration it's a test environment. Now, what happens in Kubernetes? Okay, in Kubernetes I have the pods into a namespace that's called Mercado State, and all the microservices are in this space, and all the other like Ingress and servers, networking, servers, and everything is on this namespace, including the certificates for the system. So what happens is every single server will have a different URL for this environment. In this case, is Mercado Seat Google Bit Code. Okay, so it will, I have to log in here. So let me log in here. Okay, so this is the environment, the application, and the environment. Okay, sit and the application. Now, what happens if you need to release to other environments? Well, one option is this. This is a pre-release. You could edit the tag and set as the latest, set this mark here as a pre-release and mark here as a set as the latest release. And I didn't do that yet. You update, this will be a release, not a pre-release in GitHub, and you could listen for this into a workflow. So you could create a deployment that will listen to tags or will listen to release events. And then when you release the application, you could just dispatch a new workflow. Could be the same workflow or not. You don't need to generate the image again. The image is already deployed. You just need to get the version for the release, the tag for the release. And then you could write into the realm charts in a different values. So it will be the same realm chart, but you have a different values for different environment, like for example prod. Okay, and here you could add a different namespace. So you could release to the same Kubernetes cluster, but in a different namespace. That's one option. Or you could release to a different cluster, to a different Kubernetes cluster, an entirely different Kubernetes cluster. You just need to point a different cluster into the ArgoCD. In ArgoCD, you could create a new app and select the cluster that you want to deploy. And you also select the environment. Let me check one that is here and the details. In this case, I'm using the Helm chart for the sit environment. So I could create one in the same cluster, in the same Helm charts, in the same ArgoCD, or since this is a GitOps operation, I could have an entirely different ArgoCD. In my current employee, we have a different ArgoCD for upper environments, for production environments. So we segregate the access. So it's a different ArgoCD that points to the same Helm chart, but it gets the values from the prod and the keyway and so on, and the other values for other systems, for other environments, and it will deploy to different Kubernetes clusters. If you want to segregate the application and the access, you could do that. And if you want If you want to, I don't know, for in my case, I would use the same same Kubernetes cluster because of money restrictions. I want to be a more want this to be more cheap. If you want to be more cheap, you could use the same cluster. If you want a more cheap solution, you could use the same cluster with different namespacers, and then you could segregate the access using Kubernetes AirBag, which you could delegate, and you could isolate the applications using namespaces. I think that's it for today. There's a lot to be discussed here. A lot of things that happen here. The sync of the applications, the workflow for the pipeline, and the build of the image, the pull requests, and the segregation of the system in different environments. So thank you for watching. I hope you see you soon. Peace.